Right, so today we are looking at the t-test for anxiety scores and exposure to real spiders versus pictures of spiders. Okay, so before we get started in that, I wanted to just touch on what the instructions say. So in your assignment tab, it says conduct a related t-test. However, a related t-test, the data has to come from the same group. So we would be analyzing like 12 people and exposure to both. But we have two separate groups. One group was exposed to the real spiders and one group was exposed to pictures. So what you need to do is an independent t-test. So that's what we're going to be doing. The independent t-test, you have two groups. Each group has a different exposure, and that's the data that we have. So we're going to be doing the independent t-test. Okay, so our variables, we've got exposure type, and that's here. And you'll see like 1 through 24, this is all of our sample. And then we have their anxiety level over here. So let's look at variable view. So exposure, it's numeric. The width really doesn't matter. Decimals doesn't matter. So the values, we're going to look here at values, and one, we're gonna label the group that was shown the picture as group 1, and then group 2, they had the real spider, and we're making those group value of 2. So there's that. And then we're going to go over to measure. So our exposure level needs to be nominal. That is categorical. So we have two categories of exposure type. Category 1 was the picture, and category 2 was the real spider. Anxiety, that's numeric, blah blah blah. No values because it's just a scale value, because the difference between each anxiety level is the same. So that's what you want to do there. Okay, so let's go back to data view. Okay, before we run any analysis, we want to talk about the assumptions. So there are 6 assumptions that need to be met for the data before we can run this t-test. If some of the assumptions aren't met, then you're going to look at alternative analysis methods, but we'll find that all of them are met. But let's go through each one of those. So assumption 1 is that your dependent variable is continuous. That's interval or ratio. So we did that here in variable view. That's why it's nominal. The anxiety is our dependent variable, sorry. So that's continuous. So there's a scale. And then assumption 2, our independent variable, that should be categorical, which it is, so because we've got the nominal here. Nominal is categorical. So assumptions 1 and 2 are met. Assumption number 3 is independence of observation. So let's see. So what that means is you have different participants in each group, and we do. So group 1 was exposed to the picture, group 2 was exposed to the real spider. So assumption 3 is met. Assumption 4, no significant outliers. We can kind of look at the data and see that we don't really have any significant outliers, but when we can run a test for assumption 5, and that'll give us a plot graph that'll show us that there's no real outliers. So that brings us to assumption 5. That is the data should be normally distributed. And how we're going to look at that, we are going to run a test. Let me find my notes here. So for normal distribution, we're going to analyze data. We're going to do descriptive statistics. So we're going to go up to analyze, go down to descriptive statistics, and then where'd it go? Explore. We're going to go to explore. Sorry, I'm reading my notes here. Explore. So we're going to have anxiety in the dependent list and exposures in the factor list. So that's right. Just keep this both here selected, and then we're going to go over here to statistics and check those out. So we want to leave descriptives here at 95% interval, and that's it for here. We don't need to click anything else here. So continue, and then we're going to go to plots, and then here's our box plot, factor levels together. That's checked. And then over here for descriptive, we need to do the stem and leaf, which we really won't do much with that, but we're going to run it anyway. And then we're going to make sure this box here, normality plots with tests, we need to make sure that's clicked. So all that looks good. Come down here to continue. Everything looks good, and we're going to click OK. All right, and here is our analysis, our results. Okay, so now we're going to look at our results. So because our sample size is below 50, we need to look at the Shapiro-Wilks test for normality down here, right here. So we have a significant value here of 0.215 and 0.621. Because those values are higher than the 0.05, that indicates that we do have a normal distribution. So that's good. So that meets assumption number 5. And we can scroll down a little bit and look at our plot graph and see these are all close to our line of our distribution line. There we go. They're pretty close to the center, so that just kind of backs up what we assumed for number 4, that we don't really have any significant outliers. So there's number 4. So now we've got assumptions 1 through 5 met. We can get rid of that. We'll just make that small. We'll go back to our data. So now we're looking at assumption number 6, homogeneity of variance. This will run a Levene's test to check for the homogeneity variance. Let me come here. And that actually just comes with the analysis, the t-test analysis itself. So what the homogeneity looks at is the spread of the data across the groups. And we want to make sure that those are equal. So while we're going to go ahead and run the analysis with that assumption still kind of up in the air, that's fine, because we'll get that answer when we run the t-test. Okay, so now we're going to actually run the t-test. So we're going to go up and analyze, and we're going to go to compare means and proportions, and down here to the independent samples t-test. Click that. All right, so we have, I'm going to reset this because I did it earlier, and that's okay. So our test variable is going to be our anxiety. So we need to click that over here. And then for our exposure is our group variables, and we're going to define those groups. So again, group 1 was the picture group, group 2 was our real spider. Yes. So there's that. So we're going to continue there. And then I don't know if your SPSS is edition 27 or not. The one I have is. So we have this estimated effect size. That'll come in handy later. So if you do have that, make sure that box is clicked, because that information will be helpful at the end. So we've got all that in there, so we can go ahead and click OK. All right, so here is our results. Before we look at the results, let's go down and look at the Levine's test right here. That takes us back to our assumption number 6. All right, so we want to look at the sig value, which is where'd it go? It's 0.76, which is higher, 0.076, which is higher than the 0.05. So that tells us that the assumption is met. If the significance value was lower than the 0.05, that would mean that the variables would be statistically significantly different. It's hard to say. So number 6 was met. So now we can look at the actual results. All right, so let's go back up. Let's find the two. So we can look at the means first, and you can tell that the means for the group of the picture is lower than the mean for the anxiety levels for people that had the real spiders. This 47. And then we're going to look at another one here. We're going to look at the two-sided. The two-sided P here, and we've got 0.047 and 0.409. All right, so those are lower than 0.05. So the group means are statistically significantly different, meaning that the group with the real spider had higher levels of anxiety. Okay, so that's our test. And now I want to talk just real quick about effect size. So while the t-test tells us that there's a difference between the two groups is real, it doesn't tell us what size the difference is. So that's where this effect size comes in down here. For this, we want to look at the Cohen's d, this top number here. So we want to go over here to this point estimate. The fact that it is negative indicates that the second group did have higher means, and the actual value itself, the 0.861, that indicates that it's a pretty large effect size. The negative there for that doesn't really play into that whole lot, but yeah. So our effect size was large in the means. So so there we have it. The t-test indicated that there is a difference in the means of the two groups, and that the people that were exposed to the real spiders did have higher anxiety levels, which is very understandable. All right, well, that is your t-test. If you have any questions, let me know.